The tale of life on Earth has been unfolding for about 4 billion years. And we humans are just the last word on the last page of that story, at least so far. And the vast stretches of time that are covered by the history of life can be hard for us to fathom. We rack our brains trying to imagine what a few hundred years looks like, let alone billions of years. And like speaking for myself, I can't even remember what I had for breakfast this morning. So to help us really appreciate the full expanse of time, scientists have turned to the rocks. By looking at the layers beneath our feet, geologists have been able to identify and describe crucial episodes in life's history, from bursts of evolutionary diversity to disastrous extinction events. These key events of new life and sudden death frame the chapters in the story of life on Earth. And the system that we use to bind all these chapters together is the geologic timescale. Times to reflect the latest knowledge of Earth's history. And today it's organized into 5 subgroups: eons, eras, periods, epochs, and ages. Organizing time in increments like this allows us to ask questions about history on different scales. In the largest increments, like eons and eras, we can ask the biggest of big picture questions, like, was there life on Earth? Are the largest slices of time ranging from 500 million to nearly 2 billion years long. And the earliest eon is known as the Hadean. It begins with the very formation of the Earth itself, around 4.6 billion years ago, and ends 4 billion years ago. And this is the only eon that doesn't have any fossils, because back then, the world was just hell. Named after the Greek underworld Hades, the Hadean lived up to its name. The planet was racked by volcanic activity, cosmic bombardments, raging storms, and temperatures that were at times hot enough to melt rock. But even in this searing wasteland, life may have been able to form. While no fossils have been found from this eon, small amounts of organic carbon have been discovered in Hadean rocks that some experts think is evidence of the earliest life. These first organisms were tiny and single-celled, but they were eventually able to shape the future of the entire planet. So their appearance is the one major benchmark of this eon. The Hadean was brought to an end by the cooling of the crust of the Earth, setting the stage for the continents to eventually form. And this cooling marked the beginning of the next phase, the Archaean Eon, which ran from 4 billion to 2.5 billion years ago. Named for the Greek word for origin, the Archaean was once thought to be when the first signs of life appeared. But at the very least, it's fair to say it was the first time that life flourished, forming mats of microbes in the primordial seas. The fossils that these microbes left behind are called stromatolites, or sometimes stromatoliths. And the very oldest of them, like those found in Western Australia, date from the Archaean. During this time, the atmosphere was mostly carbon dioxide. But the appearance of cyanobacteria was about to change all that. Then, 2.5 billion years ago, the Archaean gave way to the Proterozoic Eon, meaning earlier life. And around this time, photosynthetic bacteria, along with some multicellular forms of life, spewed tons of oxygen into the atmosphere. This probably wiped out most of the anaerobic life on Earth, but it cleared the path for crucial new organisms, including the ancestral eukaryotes, whose cells each had a nucleus and organelles wrapped up in membranes. Eukaryotes developed into the first really big, complex, and sometimes kinda weird forms of life, such as the frond-like Carnea and the plate-shaped Dickinsonia. These new, larger organisms quickly diversified, and by 541 million years ago, we were at the doorstep of the next and current eon, the Phanerozoic. Its name means visible life, and the Phanerozoic was when life really became obvious. This is the eon that's home to trees, dinosaurs, newts, aardvarks, us humans, basically life as we know it.